This is the example on slide 78 of our chapter 12 PowerPoint. And in this example, now that we've learned molarity, we're actually going to incorporate it into some calculations of solution stoichiometry. So we talked about stoichiometry, I should say, in a previous chapter, where you go from grams of one thing, change that into moles, then use the chemical reaction, the mole to mole ratio, to convert into moles of something else, and then eventually back into grams of something else. So we're going to be following similar steps here, but instead of going from grams to grams, in this particular problem, we're going to go from grams of one thing to liters of something else. And in the next problem we're going to go from liters or milliliters of one thing to liters or milliliters of another. So very similar setup to just regular stoichiometry, but we've now have this added unit of molarity. So the question reads, how many liters of a 1.5 molar HCl solution completely react with 5.32 grams of zinc? And they give us a balanced equation for this problem. So our game plan for this is to start with grams of zinc, use its molar mass to get into moles of zinc, then use the mole-mole factor provided basically in the equation that we can determine ourselves to go from moles of zinc to moles of HCl. And then finally, to use the molarity of HCl to convert moles into liters. So this is basically a three-step calculation. So first, I'm going to figure out, before I start plugging stuff in, I'm going to figure out the molar mass of zinc, which happens to be 65.41 grams per mole. And we're going to use that to go first from grams of zinc to moles of zinc. So ultimately, what we're looking for is liters of HCl. And we're going to start first with our grams of zinc. So 5.32 grams of zinc. And we're going to use molar mass. So grams going to go on the bottom, moles on top. We're going to use molar mass of zinc to cancel out grams of zinc. Now we're in moles of zinc. This is where we're going to look at the balanced equation and write a mole to mole ratio for that conversion. So specifically what we're looking for is moles of zinc and moles of hydrochloric acid. So for every 1 mole of zinc, 2 moles of hydrochloric acid are needed. So I can write that ratio into my equation. The thing that I want to cancel goes on bottom. So it's going to be 1 mole zinc on the bottom. 1 because there's not a coefficient in front of the zinc in our reaction. And then on top, it's what we want to get to. That's 2 moles of HCl. And that 2 comes from the fact that there's a 2 in front of our HCl in the reaction. So at this point, moles of zinc now cancel, and I'm left with moles of HCl. Ultimately, I want to be in liters, so I have one more value that I can use in my problem, this 1.5 molar HCl, which basically translates into 1.5 moles of HCl per 1 liter of that solution. So then, now that I have that, I can basically put the moles of HCl on the bottom and the liters on top. That's HCl solution. And that's going to cancel out moles of HCl. And I'm left with my liters of HCl solution, and that's what I'm trying to solve for. So if I multiply across, I multiply my 5.32 times my 2, get that number, and divide that by 65.41, and take that number and divide it by 1.5, I'm going to get an overall answer of 0.108 liters of HCl solution. And that, my friends, is your final answer.